honestly, it can feel like you need a secret decoder ring just to read a standard curriculum document. But don't worry, because today we're going to demystify all of it together. We're breaking down the master blueprint of modern college curriculum design, and we'll see exactly how all these seemingly random pieces actually fit together to create a way better experience for students. Okay, let's dive right into this. Here's our path for today. First, a welcome to outcome-based education. Second, we'll get that alphabet soup explained. Third, we're building a house as an analogy. Fourth, we'll look at how to map outcomes. And finally, number 5, the faculty mapping guide. All right, part 1. Welcome to outcome-based education. So right now, there is a massive paradigm shift happening in colleges everywhere regarding how education is delivered, and more importantly, how it's measured. To really wrap our heads around this shift, let's look at the stark contrast between traditional models and outcome-based models. Think back to traditional education. It was completely teacher-centric, right? The core question was always, what should I teach? A professor would look at a syllabus and say, okay, well, I need to teach inheritance, threads, and collections today. But outcome-based education, or OBE, takes that and flips it entirely on its head. It asks a totally student-focused question. What should students be able to achieve after learning? So instead of just teaching inheritance, the goal becomes, after this course, students should be able to develop Java applications using object-oriented programming concepts. See the difference? It's a huge shift from what is transmitted by the teacher to what is actually demonstrated by the student. Now, you might be wondering, why make this massive shift in the first place? Why is ALBI taking over? Well, fundamentally, it ensures that students are gaining practical, measurable skills. We're not just crossing our fingers and hoping they learn, we are literally proving it. This directly aligns their learning with industry needs, meaning graduates are actually ready for the workforce on day one. It also guarantees that every single piece of teaching and assessment is anchored to a specific, tangible outcome. Plus, and this is a really big one for institutions, it allows colleges to measure whether graduates are hitting those intended competencies. This is heavily recommended and supported by major accreditation bodies like the NBA or National Board of Accreditation. Moving right along to Section 2. The alphabet soup explained. So now that we know why this framework exists, let's systematically unpack the 3 core acronyms that define the whole system. We're going to move from the macro level all the way down to the micro. Starting at the very top, we have program outcomes, or POs. These describe the overarching knowledge, skills, and abilities that every single engineering graduate absolutely must possess by the time they finish their degree. Think of these as the universal standards. Accreditation bodies like the NBA usually define these, and there are typically 12 of them. We're talking about the fundamental competencies here. Things like engineering knowledge, problem analysis, ethics, and communication. Literally, no matter what kind of engineer you are studying to be, you are expected to achieve these 12 POs. Next up, we step down one level to program-specific outcomes, or PSOs. As the name kind of gives away, these are outcomes that are completely specific to a particular academic program or department. Unlike those 12 universal POs we just talked about, these change entirely depending on your major. If you're in information technology, your PSOs might be all about designing database applications or maybe applying cybersecurity. But if you're over in mechanical engineering, your PSOs are going to focus on totally different things, like manufacturing processes, thermal systems, and CAD/CAM. Now, what's really interesting about looking at these side by side is seeing exactly where these definitions come from. POs, they are common to all engineering programs and defined by external bodies, like the NBA. You've usually got 12 of them. Side by side is seeing exactly where these definitions come from. POs, they are common to all engineering programs and defined by external bodies, like the NBA. You've usually got 12 of them. PSOs, on the other hand, are highly specific to just one department. They're defined internally by that specific department's faculty, and you usually only have, say, 2 to 4 of them to represent those specialized niche competencies. And finally, we zoom all the way into the micro level, course outcomes, or COs. Every single subject has its own COs. These are the highly granular, measurable abilities that students are gaining on the ground every single week. Take this Java programming lab as an example. CO1 is develop Java programs using classes and methods. CO3 is implement multi-threading. CO5 is develop database apps using JDBC. See how specific that is? These are the actual day-to-day building blocks happening right inside the classroom. Section 3, building a house, an analogy. Look, I know all these acronyms can feel incredibly overwhelming, so let's try to visualize an engineering degree like building a house. It's a great way to see how all these pieces perfectly synthesize. The course outcomes, those COs, they are the individual rooms you construct. The bedroom, the kitchen, the living room, they're the granular building blocks. Now, the program outcomes, the POs, those represent the complete house and its fundamental integrity. We're talking its structural safety, its overall functionality, its basic comfort. You obviously need all the rooms to build the house, right? And finally, the program-specific outcomes, the PSOs, are those special custom features added based on the owner's specific needs, like maybe a built-in home office, a smart home system, or solar power on the roof. Every room, the CO, contributes to the overall house, the PO, while the special features, the PSOs, make it perfectly suited for its specific purpose, whether that's IT or mechanical engineering. All right, Section 4, How to Map Outcomes. So how do we actually prove that the rooms we're building are resulting in a structurally sound house? Well, we map them. And this brilliantly illustrates how faculty actually link these different outcomes together in practice, usually using spreadsheets. Let's look at CO1, Design and Implement Java Programs. When we map this to our universal program outcomes, we use a 1 to 3 scale. PO3 is Design and Development of Solutions. Since designing Java apps is the absolute main focus here, this gets a high mapping, a solid score of 3. But look at PO2, Problem Analysis. Students definitely have to analyze the problem before they start coding, but it's not the primary objective of this specific outcome. So that gets a medium mapping, a score of 2. Finally, check out PO10, Communication. Students might have to explain their code during, say, a Viva exam, but communication is really only involved to a very limited extent here, so it gets a low mapping, a score of 1. Now, let's quickly contrast that with CO5, Develop Database Apps using JDBC. Because this is such a comprehensive, highly technical task, it triggers strong mappings across the board. Building a database app applies core engineering knowledge, problem analysis, and complete solution design. So POs 1, 2, and 3 all get a strong score of 3. Because they're using modern tools like MySQL, PO5 gets a 3. And importantly, because database development is a very key specific skill for an IT student, it also scores a 3 for both PSO1 and PSO2. You can really see how this one rigorous course outcome heavily supports the entire program's goals. And that brings us to Section 5, the Faculty Mapping Guide. So the crucial point is, how can faculty actually sit down and do this mapping without pulling their hair out? Well, the source material gives us this incredibly simple 4-step checklist. Just follow these steps when you're looking at your spreadsheet, comparing a course outcome to a program outcome. Step 1, ask yourself, does this course outcome directly achieve the program outcome? If yes, give it a 3. Simple. Step 2, does it support the program outcome, but it's just not the main focus? If yes, assign a 2. Step 3, is there only a slight peripheral contribution, like, briefly explaining code? Assign a 1. And finally, step 4, if there is absolutely no meaningful relationship, for example, a Java coding lab probably doesn't relate much to PO7, which is environment and sustainability, just leave the cell blank. It is honestly that straightforward. Ultimately, outcome-based education isn't just some bureaucratic exercise to satisfy accreditation boards. It is about fundamentally re-engineering how we think about student success. By understanding and properly mapping our POs, PSOs, and COs, we ensure that every single lecture, every lab, and every assignment is intentionally building towards a capable, industry-ready graduate. Which leaves us with one final thought to ponder as you go back and look at your own curriculum. Are your courses truly designed for what students will achieve, or are they just designed for what you prefer to teach? Thank you so much for joining me for this explainer, and I hope you leave today feeling empowered to build a better blueprint for your students.